Okay, we have to start. Okay, hello everyone. So this is a BESS working group session in Yokohama. Thank you everyone for being here. This is the IETF Notewell. If you are not aware of it, please read it. So, few meeting tips. This is still a kind of hybrid meeting. So for everybody which are in the room, make sure you are signing in into Meeteco, so we know that you are attending the session. If you want to go to the mic, please go into the virtual queue, so we can allocate you a slot to talk. And please ensure that you are wearing your mask unless you are speaking at the mic. And for remote participants, of course, please keep you muted, and we will allow you to speak when it will be your turn in the virtual queue. So this is our agenda. It's pretty packed. We just have 10 minutes of buffer. So for all the speakers, please keep the time slot that you have. We have almost no possible overlap. Status update. We don't have any new RFC published since the last IETF. We still have 2 RFCs that are in the RFC editor queue for a misref reason. So as soon as the misref are resolved, these documents will be published. We have bunches of documents that are still on your side, Andrew, and where we need some
Yes, there are a ton of documents which directly after this meeting are either going into last call or going to the ISG. It is quite a queue. So within the next probably week or 2, you'll see a whole bunch of progress across all those documents right after this meeting.
Okay, thank you. But just for information, it's also causing us some trouble because for us it becomes harder to move you additional documents because it's creating even additional bottleneck.
Yes, no, I'm fully aware. Sorry, there was quite a long queue of documents from all over the place. But as I said, there is a very clear queue reduction plan in the works at the moment.
Okay. So we have also bunches of documents under Shepherd review. So some of them are still, I would say, pending some routing directorate review. Some of them we just asked for the routing directorate review. So we have to wait to get the feedback from the reviewer, the comments to be addressed before we can move to the next step. Regarding the FastDF recovery draft, it seems that the document is expired now. So if at least you can refresh it so we can. Cool. Thank you. And for MHPA, I don't know, Luc-André, if it's also on your plate. I think there was no reply to the comments from the routing directorate. Okay, cool. And something that I have highlighted to the IDR chairs offline. So we still need to have the review from Kiyur about the unequal cost load balancing before also we can move to the next step. We don't have any document in working group last call for now. We have two documents that are ready for working group last call. So we will probably wait a little bit before doing the working group last call for this document, just to avoid additional bottlenecks. But as soon as the situation becomes more clear, we will progress them as fast as we can. We have also bunches of documents in our adoption call queue. So we really apologize. We were not really good people over the past weeks and months. So we have to do a better job and drain this queue as soon as possible. So we will make an action plan with Matthew after this IETF and schedule the associated adoption call. Working group document status. So we still have a lot of working group documents. One complaint that we have as chairs to the working group is usually at the IETF, we see a lot of presentations of new individual documents, but we are getting very, very few updates on the existing working group documents. So we would like to see more frequent update about the existing working group document, because at some point, I would say it becomes even harder to accept more work if we are not able to handle what is already ongoing. So there are a couple of drafts where we don't really know what is the current situation. So for instance, Jeffrey, I think the BGP multicast drafts are all expired today. Maybe your mic is turned off. Could you check?
Okay, Jeffrey from Juniper. Those BGP multicast 2 drafts, I got sidetracked and I need to get back to it, but I will right after this meeting.
Okay.
Thank you.
Thank you. When?
Hi, Wen. From a Juniper, there's also a working group document, and extended optimized ingress replication has been there for a long time. Could you add that to? Or you have another page to list
Optimized IR. Yeah, there is another page.
Okay.
Yeah,
Okay.
absolutely. It's
All right,
tracked
thank
here. Yeah. Okay, so I think we are done on our side, so we can probably move to the first presentation. So first presenter, I think it's you, Mankamana.
Good morning.
Turn on your mic. No button?
Good morning. Yeah. So Mankamna Misra from Cisco, and I'll be presenting some updates on behalf of other authors. Can we go to the next slide? So since we presented this draft, I think twice, and it's been quite long, we were waiting on IGMP proxy draft to move forward before going to the next step for this. So it is just a problem statement recap. When we have DF election today, it is by default based on 7432, it is per ESI per EVI. So in this case, if you have multicast deployment where you may have huge amount of flows which are coming towards the access side, all the traffic is going to come from one PE, and that may kind of add extra load in case of any failure. All the flows have to move around the PEs, and that may cause some extra convergence issues. And that is where we came up with the new scheme of DF election for multicast traffic. We can go to the next. So with new scheme of DF election procedure, what we are trying to do, we are trying to differentiate between broadcast, unknown unicast with multicast. So broadcast and unknown unicast remains as is the way it is today. And only for multicast, by default, you could be in the block state. And we do DF election as and when we get a join. So if we are having multi-homing peer, we are anyway using IGMP or multicast sync procedures. So when one of the PE is getting joined, anyway, join is going to other side as well. And that is the time when we are doing the DF election. And we are using HRW algorithm to make sure that load balancing is happening between both of the P's fairly. So I won't say it is exact 50-50%, but it is somewhere between 55 to 45 kind of percentage. And this is what we have defined in this draft. It is defined for SG joins, it is defined for star G joins, both of the scenarios. Next. Implementation wise, yes, it is already been implemented and deployed in Cisco. And we think that document is ready for working group last call. Today morning, I was just looking at some previous emails and I figured out that there was a comment on one of the section about IANA allocation, where I think some of the bits we are using based on the other DF drafts. So that is a section which I'll modify, and then document is ready for last call. If there is any question. Thank you.
Thank you. Next presenter, Luc-André.
Good morning. I'll start by presenting an update of the L2 Gateway Protocol document. This document has been in the working group for some time now, and it has progressed. In the latest version 3, we've updated the section on the MAC mobility to clarify the procedures of MAC mobility in single flow active mode, in this L2 Gateway Proto single flow active mode. The difference between inter and intra subnet mobility is explicitly addressed. There was a new section added based on feedback to handle explicitly MAC duplication behavior. So this addresses concerns with extremely frequent MAC mobility within an ESI, which is supported in L2 Gateway Protocol, may lead to false duplicate MAC detection. So there's a recommendation made in the document to effectively put the MAC dupe timers larger than those that exist in the access. The document itself is mature now. There are implementations, and it has received feedback and reviews from several vendors and operators. So it is ready to progress soon to working group last call.
Any question on this draft? Okay, I think you are also the next presenter.
Yep. So I'll present now an update to the EVPN L2FRR document. This version 5 addresses several comments we received on the draft, on the document, to incorporate L2FRR procedures for other load balancing modes. So previously, it included only all active and single active. But based on feedback we received, we realized that effectively this should apply across the board to others like single flow active and port active. So those are added explicitly into the document. And more importantly, in this version 5, we have extended sections for the support of new underlays. So VXLAN tunnels and SRv6 support is added also. So the procedures for SRv6 are defined by the addition of 2 new behaviors. A variant of n.dt2u that we call n.dt2u reroute, and a variant of n.dx2, which we named ndx2 reroute, which I'll go into on the next slide. So the new end.reroute behaviors are signaled in parallel and alongside the base behavior. So if I have, for example, a base n.dt2u behavior that is being signaled in BGP, the similar or the associated flavor n.dt2u reroute, which I have an example here, that sub-TLV is included alongside the n.dt2u with one notable difference. The n.dt2u reroute includes an argument. So this argument is effectively the per EVI per ESI destination of the reroute, which specifies specifically on a reroute packet which AC or which per EVI per ESI subinterface to target. The reason this was done this way is because the advertisement of this reroute or the resulting IPv6 address of this reroute makes no change in IGP. We do not need to advertise this anywhere other than in BGP. And the only change locally is the inclusion of a new forwarding behavior in the FIB, which would know that it has to implement the behaviors defined further up in this document for the terminal disposition and loop avoidance. Sorry, loop avoidance and DF bypass. On the next slide. So as I mentioned, we have implementations of this document in Cisco iOS XR. The document is important because it represents an extremely simple way of achieving fast convergence in EVPN. And with SRv6 now especially included in the document and VXLAN, we consider the document to be complete, that the solution itself is complete. So we would like the working group to look into this document in greater detail, provide feedback, and we will be eventually seeking soon. I know the queue is a bit long, but we will be seeking working group adoption of this document.
Quick question: has this already been presented to Spring?
It has not.
I think you should.
Okay.
At least for the new
For the behavior.
for the behavior that you are
Perfect.
doing.
Okay.
And we may need some, I would say, support from Spring before
Review
moving
and support
forward.
from Spring. Okay. Thank you. Are there any other questions? I think that's it.
Next presenter,
Thank you.
when?
Hi, and I'm Wen from Juniper. I'm presenting on behalf of the co-authors today for extended optimized ingress replication for EVPN. This draft has been there. Next slide, please. Yeah. So it has been there for a long time. Just update since the last presentation. So first, a recap about ingress replication. So just back to illustrate was two diagram before. So in the NVO networks, and especially this is a feature is useful in ingress replication, where you can see when ingress replication is used, let's assume the multicast traffic is now using underlay PIM in this use case we're targeting. And so without optimized ingress replication, in order to send multicast traffic to the receiver, in order leaves from the ingress leaf node traffic has to be duplicated X number of copy. X is equals to number of the leaf who is interested in receive this multicast packet. With optimized ingress replication, so we're using the spine as a replicate node to duplicate the traffic. This saved uplink bandwidth, right? The obvious advantage is in the cross data center IP cross network is to save the bandwidth and also reduce the number of the copy from the leaf to the ingress node to the spine node. So this is just a recap for ingress, optimized ingress replication. Next slide, please. So what is extended optimized ingress replication? So ingress, this is a procedure is extending the optimized ingress replication to support multi-homing. Because when replicator is trying to replicate a packet, we lose the original source IP address or the ES label. So the extended optimized ingress replication is to add support for multi-homing and to simplify the procedure for the protocol. So it works in this way, the multi-home, the ingress leaf will replicate the packet to his peer multi-homed leaf by itself, and the rest will be replicated by the replicator. Because the replicator is the spine is unable to keep the original IP address, like local bias, for example, is used for EVPN VXLAN for duplicate the multicast packet. So that is the this extended optimized ingress replication draft is for. Okay, thank you. So what we have compared to the couple of years ago, the presentation is what we add. The only change is we got a INA X the bit for to specify the replicator is capable to implement this procedure to support multi-homing. Next slide, please. Thank you. So the status for this draft, we have implementation for years, and it's also deployed in the field. We are thinking it's ready for the last call, so just want to request for the last call for this draft. Thank you.
Is there any question? Ali, go ahead. You need to unmute yourself, Ali.
Can you guys hear me?
Yeah, we can hear you now.
Okay. So when you say multi-homing, do you basically mean all active multi-homing?
Yeah,
Or does
so
it
active
also?
multi-homing. Yes, so this is the most common use in the data center. Usually, you could have more than one leaves multi-home together. The diagram I choose just have just a common deployment. You have a pair of leaf doing active in the data center for EVPN VXLAN.
Right. So for single active, we can use the baseline optimized IR, not the extended version, right?
For this is really to do with how multi-homing is work for EVPN VXLAN. For the single active case, you're not gonna have this problem to start with because
Right.
the non-DF will drop the traffic. But you do need this procedure. Yeah, you do need this procedure for the replicator, who is the spine, to understand whether he needs to replicate the traffic to the leaf. Because otherwise, the spine will send the traffic to the leaf. It will be dropped, which is a kind of a waste of bandwidth to start with. It does not does not break the functions, but this procedure also help to save the bandwidth because whether it's DF and non-DF, the knowledge of DF and non-DF is kept only between the multi-home peer, right? Spine has no knowledge about this. So I would think this procedure also help to save the bandwidth because overall, basically the difference between this optimized ingress replication and extended optimized ingress replication is basically the replicator. In this case, the spine does not need to send a packet to the multi-home pair of the ingress leaf. Maybe you can show the diagram. Yeah, thank you very much. Yeah. So in a single active case, the P2, which is another leaf, he does not need to receive the packet at all to start with because of single active. And there will be a saving in this case. Yeah, thank you for the questions. Yeah.
Patrice, you had a question or no? Okay. Thank you, Wen.
Thank you.
Ali, you are the next presenter. Ali. I think we lost Ali. Yeah. Krishna, do you want to move to your presentation and we can come back to Ali after? Thank you. You can start.
Yeah, thanks. Hey, I'm Krishna Swami from Cisco Systems. I'm going to present EVPN first off security draft. Next slide, please. Yeah. So before we get started with EVPN first off security, we want to just understand what is the idea behind the first off security, right? So first off security requires a DHCP snooping, which means the Snoop database stores the valid IPv4, IPv6 to the MAC binding by snooping the DHCP messages. The ARP inspection, ND and IPv6 source guard and IPv4 source guard, right? So they make use of these bindings to provide the first off security feature. So FHS is widely deployed on access switches, but currently there is no standard-based multi-homing and host mobility handled. So as a part of this draft, we are defining a new EVPN route type and the procedures to handle the multi-homing and also the host mobility. Next slide, please. So the requirements, the top 3 requirements for this draft is to support the multi-homing, which includes both all active and single active, and host mobility when the PEs are participating in the same EVPN instance, and of course to support both bridge and IRB service. So before we get started on how we are going to address this on EVPN, so a quick background on how the DHCP Snoop database is built. All right, so DHCP Snoop database built based on the DHCP messages, which is popularly called as DORA, discover, offer, request, and ACK messages. In this particular topology, the client is behind the switch 1 and the DHCP server is behind the switch 2. When the client requests a DHCP discover message, which is a broadcast message, all right, so which lands on switch 2, and the DHCP server responds to that with an offer. The offer could be a unicast or a broadcast, and there could be a multiple DHCP servers, which could respond with an offer message. The client is going to choose the one of the DHCP server, and it's going to send a unicast request message to the DHCP server. For that, the server is going to acknowledge. So this complete procedure, completes the DHCP DORA exchange. Now, only request and ACK are the ones which are being used to build the DHCP snooping entry. Next slide, please. Yeah. So this is the new route type that we are defining. This more or less, looks like a type 2 route without the labels. Since DHCP, the Snoop binding is MAC and IP, then there is also a lease time which the server allocates. So that way, if the host doesn't do the renewal within certain point of time, then this entry is going to be removed, and we are going to make use of the same thing for the EVPN, and I have a slide further which explains this. Okay. So how is this DHCP Snoop route is getting originated, right? So this will be originated by the PE, where the host is connected, which does the DORA exchange. And in the draft, we call this DHCP Snoop anchor PE. And whenever on the receiving PE, it going to install this DHCP Snoop entry as a remote, and so that way, when the host moves, so it can refer to the DHCP Snoop entry, and it could pass the first half security. And how is this being withdrawn? So when the lease timer expires on the anchor PE, then this DHCP Snoop route will be withdrawn from the fabric. Then DHCP also has this mechanism of lease renewal, and whenever the lease renewal happens, so we have the anchor PE has to send with the updated lease time. As I explained, the lease time is needed as a mechanism in which if the host does not do the renewal and that entry needs to be removed, when the DHCP Snoop route is advertised in the fabric, once the host moves to a new location, ideally it will do a renewal once the lease time expires. But if it doesn't do the renewal, then we need to have a mechanism in which we have to remove that the entry from the fabric. So that's the reason the remaining the lease time is being included. I have some wordings here, but I have a pictorial representation in the next couple of slides, so probably that will explain. Yeah. So in the step one, the fabric has only PE1, PE2, and a RR, and the host is sitting behind the PE1. After the DORA exchange, the PE1 originates this DHCP Snoop route with the lease time, let's say 10 hours. Then the RR is going to reflect this information to PE2, and the PE2 will install the same with lease time as 10 hours. So at step 3, the new PE3 is added into the fabric. Now RR is going to send the up DHCP Snoop route to the PE3. At this point of time, right, if it just make use of the lease time, then it's going to send 10 hours. Then PE3 is going to start the timer for 10 hours. And once the host moves, so it is actually keeping the entry for 4 more hours if the host does not do the renewal. So in order to solve this issue, go to the next slide. So what we are proposing is on RR, right? So it can maintain a timestamp of what time the DHCP Snoop is received, and while advertising this Snoop route to the peers, it can calculate, it can get the current time, and it can subtract that advertisement time with the time the route was received, minus the lease time what it has received, right? So that way, in this case, in the step 4, the RR is actually advertising the with the lease time as 6 hours. So that way PE3 can keep the time as 6 hours. And this is just a PE3 addition, and the BGP speaker can send a route refresh message anytime, and so it is the responsibility of the sending the BGP speaker to advertise the appropriate lease time. Next slide, please. Yeah, so we will look into the bridge service and followed by the IRB service. So as we said, one of the requirement is to support the multi-homing. So in this sample topology, we have a DHCP client sitting behind the PE2 and PE3, which are multi-homed. It could be a single active multi-homing, or it could be all active multi-homing, and the DHCP server is behind the PE1. So in case of a single active multi-homing, all the DORA messages will arrive on a single PE. So that active PE will be the one which will be the anchor PE, and that's the one which is going to originate the DHCP Snoop route. In case of all active multi-homing, right, so the client can send this the discover message to either PE2 or PE3. Let's say it sends it to the PE2, then PE2 broadcasts this, and it reaches to the PE1, and the DHCP server responds with an offer. Now this offer could be a broadcast, and this broadcast message will be received on both PE2 and PE3. And let's say if the PE3 is the DF for that particular VLAN, then PE3 is the one which is going to send that the offer message to the client. For this, the client is going to send a DHCP request, which is a unicast, because it already knows that the DHCP server, the address. So let's say it could land on P2, then P2 will still, it will, since it has already learned the DHCP servers, the MAC address, so it's going to send it to the PE1. The response to the request will be an ACK, but the ACK on PE1, even though it's a unicast, right? So since the DORA exchange is not complete, so there will not be a MAC or a host learning on PE2 and PE3. So the PE1 will end up broadcasting it, and it could land on PE2 or a PE3. Then that's how the DHCP, the anchor will be get created, and it is going to initiate the DHCP snoop route. Now, as a part of this procedure, right, we don't need to synchronize the individual DORA messages between the PE2 and PE3. Rather, whichever is the one, the anchor PE which gets selected, is the one which is going to initiate the DHCP route with the ESI and either P2 or a P3. After receiving it, it identifies that this is part of the multi-homed peer.
So you have to go a bit faster because I see you have a lot of slides, less than 2 minutes.
Okay, sure. So yeah, so the IRB service is a quite similar, except that in case of an IRB service, we will have a DHCP relay instead of the DHCP, instead of flooding there. So you can go to the next slide, and these things are covered in the draft, and people can go and review it. So this is the last aspect. How do we bring the DHCP and snoop anchor the mobility? So after the host moves, right, which will be determined by the GARP or a RARP. So DHCP entry, since DHCP entry is already present there in the snooping table, so this will go through, and it is going to initiate the mobility.
You have to conclude if you want to take questions.
Okay. Sure. So the one last point here is it is going to make use of the existing the MAC mobility extended community to whenever this anchor moves. So that way, with the highest sequence number, is going to identify that that's the one which is the latest the anchor. Yeah, I think I'm open for questions. Go ahead.
Keyor, you can start.
Not really.
Can you hear me?
Yeah.
Keyor Patel Arcus. Thank you. Quick question. You said the timer would be about 10 hours. I'm assuming that's a default timer?
No, I just picked up that as an example.
Does the draft mention what happens if the connections flap? Are you going to withdraw all this discovered routes and then re-announce it?
That's correct, because when they re-announce it, the originating PE is also going to run the same algorithm, so that way it is not going to send 10, it is going to send the...
One follow-up quick question. Sure. Does that mean that the receiving PE will pull back the DHCP announcements that it's been doing with the host requests, or where it's proxying because the routes are pulled back?
No. See, the snoop route will still present in the DHCP table, but in the BGP table, right, that's where the DHCP snoop route will be, right? So that's not going to be pulled down.
Jorge.
Yeah, Jorge Rabadan, Nokia. Yeah, thanks for this. Did I get it right that when in the slide where you had the diagram, when the new PE shows up, is the route reflector changing the remaining time?
Correct. That's right.
So the route reflector is no longer a route reflector, right? It's changing the NLRI of the route.
That is true. That's correct.
Okay, that should be clarified.
And
okay. my other question,
I will add the clarification.
Cool, thank you. My other question would be, in order to choose the anchor PE, you only need to snoop the ACK message, right? Or you need to keep state for the 4 messages?
No, just the request and the ACK. And once, because the request is going to create the entry, and it will make the entry as a false. And once the ACK comes, that's when the it gets into the true state.
But in reality, you would only need the ACK message, really, right? That's the one you are into.
Right. So that is anyway like outside the scope of how the DHCP Snoop entry gets created. So that we are not defining as a part of this draft. But if the implementation has something like that, only the ACK is going to create the DHCP Snoop entry. So from the EVPN perspective, DHCP is a client and which provides this information to EVPN. Yeah.
Okay, gotcha. Thank you.
Thanks.
I won't take a lot of time. Keyur Patel Arcus, just a note to chairs and the presenter. Speaking as a working group chair for IDR, you may want to socialize this in IDR, knowing that you're altering route reflection rules and you're carrying discovery messages within BGP. Might make sense to socialize it.
Fully agree. Yeah.
Yeah. Thanks, Keyur. Thanks, guys.
Ali, you wanted to mention something? I see you in the queue. No. Thank you, Krishna.
Okay, thanks.
Ali, you are the next presenter. Okay, we will see.
All right.
No, it's not coming.
Mankamana, can you share my UMR slide?
You want to start
I'm
with
sharing
UMR?
it, but I'm not sure whether you guys can see it or not.
No, we can't. We can't. Let me share them. Normally, Mankamana has uploaded them in the data tracker. UMR. Okay, please go ahead.
Very
Ali.
good. Thank you. So this draft is about the unknown MAC route mobility, and these are the co-authors, and I'm presenting on their behalf. So next slide, please. Problem statement. Unknown MAC route can be used to improve MAC address scale on the leaf nodes, aka PEs, to considerably improve the scale of the MAC addresses. And it does that by limiting the MAC address learning on the leaf node or PE to that of its own network, without learning MAC addresses from the remote network. So if, for example, you have 10 data centers and the EVI, the Ethernet Ethernet instance goes across all 10 data center, then the leaf nodes on a given data center needs to only learn the MAC addresses of its own data center and not the other 9 data centers. So it gives you quite a bit of a scale improvement. The RFC 9014 has defined these UMR. However, the procedure, the mobility procedure for it is not being defined there. And basically, the mobility procedure is impacted, a MAC mobility procedure. And this draft talks about what the impact is and how to remedy it. Next slide, please. Requirements. Basically, all leaf nodes in a DC network need to support UMR. You cannot have some leaf nodes supported and some leaf node don't, and be able to do this operation properly. So either a network can be partitioned into 2 logical networks, one with the UMR support or not, and or the other way of doing it is basically upgrade all the leaf nodes or PEs, and then once everything is upgraded, you can turn on the UMR procedure. That's another way of doing it. So the UMR procedure is optional, and it gets turned on the leaf node once it receives the UMR route from the gateway. So that makes it easy to upgrade the network for this capability. Also, if one network is UMR capable and another network is not, still the mobility procedure needs to work seamlessly, and it is going to be so. Next slide, please. So before getting into how these UMR mobility works, here I'm giving you guys a primer of how the network works, how the MAC mobility works without the UMR. So we got the two networks, one on the left, one on the right, and they are connected via the interconnect or WAN network, and gateway 1 and gateway 2 are sitting at the edge of the WAN network. So the host first appears on the PE11, and the PE11 advertises the MAC address that it learned to all the nodes within its network, and that includes PE12 and gateway 1. And this advertisement goes without the MAC mobility extended community because it is the first time that the host has learned it, the PE has learned it. And this gets propagated to all other nodes in the other network. So gateway 1 sends it to the gateway 2, and that is via the procedure of 9014. And gateway 2 propagates it to the nodes within its own network. So far, so good. This is, again, 9014, RFC 9014. Now, if the host moves within the left network from PE11 to PE12, that move gets propagated to other networks, as you can see. So the PE12 that has learned the MAC, it advertises it with the sequence number 1, and gateway 1 receives it, and gateway 1 advertises it to gateway 2, and so forth. It gets propagated. So you can see a mobility in one network affects other network, and everybody, all the leaf nodes, all the PEs learn the MAC addresses of the other networks. And if the move goes from, if the host moves from left network to the right-hand side network, as you can see, the PE21 learns it and advertises it with the sequence number 2, and that gets propagated to gateway 2, and gateway 2 in turn sends it to the gateway 1, and gateway 1 uses that higher sequence number and propagates it to its own network, and PE12, when it receives it, it realizes that there has been a move, and PE12 withdraws its MAC address. And the last set of ladder diagram, it shows that if the move again happens within the right-hand side network, the mobility messages gets propagated to other network. So this is the baseline scenario that we have, and we want to see how we can improve that. Next slide, please.
You just have 3 minutes left, Ali.
3 minutes? Okay. Okay, next slide. Okay. So for the UMR, actually, I'm sorry, let's go back to the previous slide because the previous slide says that now we want to keep, in order to take care of the mobility and in order to self-contain the move within a given network to that network only, we use two MAC counters, one for the intra and one for the inter network or inter DC. And these two counters get incremented independently, and a local MAC move doesn't impact the DCI counter. So next slide. So in here, it shows that if the host is learned within on PE11 and it gets advertised to gateway 1, gateway 1 advertises it to the other gateways, but the other gateways, gateway 2 doesn't propagate it to its own PEs. And then the next diagram, the next ladder diagram shows that if the host moves within the left-hand side network, that move is not get impacted and doesn't get propagated to the other guys, okay? Only when the host moves from one network to the another network, you will see that, you know, the messages gets propagated. And in here, when the host moves from PE11 to PE21, then PE21 learns it and sends it to the gateway 2, and gateway 2 advertises that with its inter DC sequence number of 1 because it has realized that there is a move, and sends it to gateway 1, and gateway 1 advertises that in turn with a sequence number 2 for the intra DC, not for the inter. Then after that, the PE12 realizes that there has been a move and it withdraws its MAC, and the withdrawal also gets propagated among the gateways. And then after that, if there is a move at the bottom, you know, the arrows at the toward the end, the move on the right-hand network that gets confined to that network alone. That is for the UMR procedure. Next slide, please.
You have to conclude, Ali.
Okay. Duplicate MAC addresses is done the same as RFC, and no need to update the counter. Next slide. Basically, we need to, there are a couple of things that needs to get added and in the draft, but this is, as a starting point, is I think is a pretty good starting point, and we want to solicit more input from the working group on this. Okay. Questions, please?
You have a question. Please.
Here, Patel Arcus. Ali, you are suggesting another counter to handle the intra versus an inter DCI case. Maybe that would apply also across the AS. One feedback I have for the authors is instead defining counters that goes and attacks different use cases or intra versus inter AS case. Maybe consider thinking about announcement rules and say what should be the announcement rules so we avoid using bunch of counters to handle each and every use case. That would be my feedback. Thank you so much.
All right, thanks. Just a quick thing, the gateways can be going across multiple ASs, and it would be okay. I mean, the mobility within the WAN gets detected by that inter DC or WAN counter. But I'm open if if there are other ways of taking care of the move. I am open to that as well. The Mac move.
No further question. Thank you, Ali. So you are still the next presenter. Do you want to go ahead with 7432 bis?
Yes, please.
Okay.
All right. So this is an update on the last set of changes to this draft. This draft has been soaking in the sun so much that it's turning brown. So we basically we think we are at the point that we want to request for the working group last call, and you will see. So next slide, please. So the changes relative to the previous rev is clarification of the route key processing, because there were some question of when you talk about the prefix, what do you mean by the prefix? So we put a paragraph at the beginning of the document to describe what we mean by the prefix when we talk about the route key processing of the prefix. And that's the, if BGP route is being considered as RD plus prefix, when we talk about prefix, is that BGP route without the RD part. So next slide, please. We added a new section to explicitly describe the mismatch behavior for EVPN L2 attribute negotiation. And we talk about what happens when there is a mismatch of the MTU, what is the mismatch of the control word or the flow label flags. Basically, in a nutshell, with respect to all three of them, it says that if you receive an advertisement with these flags and the value is different than what you have been configured locally, you basically don't establish a connection, don't do this, adhere to the services for the remote. Don't honor those services, whether it is L2 or IRB or whatever, multicast, whatever that is. So we only when it is consistent configuration between what you receive and what you have locally, then you honor the messages. Next slide, please. We added clarification for signaling primary and backup PE in L2 attribute extended community. We made the language, we made it explicit that if you are using only two PEs, if you're talking about dual homing, you may want to advertise the primary and backup bits. And basically it is optional, because with two PEs, the remote guy can figure out who's the primary, who's the backup. But if there are three or more PEs, then we recommend advertising the P and B bits, and we use the language should, because if you don't do that, then if the primary fails, the remote guy doesn't know whose the backup is, and that prolongs the convergence time. And it says also, we clarify that if we need to send L2 attribute extended community, you send it with the Ether AD per EBI route. Next slide, please. We clarify the text for VLAN aware bundle service, and the clarification, thanks to Sasha for helping with this clarification and pointing out that, the text need to be further improved with respect to what should be done and what may be done. Without getting into too much of details, is for the VLAN Aware Bundle service, when you advertise the label can either represent the EVI or EVI plus VLAN. And we are recommending that it should represent EVI plus VLAN to avoid additional lookup. And if somebody wants to do the additional lookup, then we made it optional and we're saying may. Okay. However, this is purely disposition operation, and the egress PE needs to take care of it, and it doesn't impact the general operation of EVPN. I mean, the other PEs, they don't know whether you use a label for EVI alone or EVI plus VLAN. So however, we wanted to clarify the disposition operation, what it should be and what may versus should. Okay, next slide, please. Also, we clarified the text in section 18 for deep packet inspection. What is a must and what is a should, and I'm not going to go through that. Next slide, please. Next steps. Basically, we took our time, frankly, with this draft, and the reason for that, we wanted to make sure once we are done with this draft, we don't have another BIS for it. Okay, we've made considerable improvement and clarification, and we think we are sitting at a good place right now, and we like to ask for the working group last call. There are a couple of other needs that can be taken care of. But we can take care of those needs while we have the working group last call review in progress. That's my ask. And any question, comments?
John, you can unmute yourself and ask your question. John, you can go ahead.
John, we cannot hear you. Do I need to mute myself in order for John to talk?
No. He should be able to.
John, use the sign language.
Yeah, you should be able to speak now.
I'm so sorry. I was just going to say, I am very pleased with the way this document has turned out. We have clarified any number of things that were just sort of open issues that everybody sort of figured out on the way to interoperability, but I think it's a much better document than the original.
Okay, thank you.
Thank you.
Quick question, Ali. As part of all the changes that have been done, is there any possible impact over the backward compatibility of this change, or there is absolutely no impact on the existing implementations?
We've taken pretty good caution to make sure that if things are not done as we specify, still it works. Like with respect to the L2 layer 2 attribute extended community. If you don't have the P and B bits, still the stuff works, but it works in a not non-optimal way. Off top of my head, frankly, I cannot see any interrupt issue off top of my head. It's basically mainly there are clarification and mainly for optimization stuff.
John, you want to add something?
I think Ali is exactly right. We have gone through hoops trying to make sure that we didn't impact backwards compatibility.
Okay, very good. Thank you. And I think, Ali, it's still you with Secure EVPN now.
Right.
Let me share the slides. So please stick to your 5 minutes, otherwise we will be over time.
Actually, this is going to be shorter than 5 minutes because the slide deck that you have is a non-revised version, which is much shorter. But let's go with that. This is next slide, please. As you can tell from the history, this draft has been around for quite a while. The latest Rev is just a refresh. I didn't add anything. Although there are a couple of areas that need clarification, but that can be done later. Currently, the draft has quite much of meat in it, and it covers very nicely the point-to-multipoint BGP signaling procedure to do for initiation of the security association as well as for rekeying, and it talks about what BGP messages to get exchange to exchange the public key and nonce and policy and so forth. And also it talks about the different level of granularity that we can have. Once you have that IPsec session, you can use it for at the PE level between a pair of PEs, or you can do it at the tenant level, or you can do it at the EVI level, or even down to individual flow level. So it gets to that level of granular, that we can have this level of granularity and all that. I had a slide on each of those, but it didn't get to this,
Monkamana is telling me that it should be your last version.
So
just tell me. I will go through the slides, and you tell me if it's.
No, that's what I'm saying. I mean, it doesn't have this slide.
Okay.
This deck doesn't have much. So it talks about the two types of the encapsulation. One, when you have the IPsec transport mode, either put it encapsulated further within a UDP in order to enable ECMP load balancing, or in order to do NAT traversal, or if you don't need to do NAT or ECMP, then you can just go with the basic IPsec transport mode. And it covers that, and then it also talks about how to signal to establish this tunnel and so forth. The use cases in here also been mentioned in the SD-WAN use cases or usage, Linda's draft. And basically, I've been asked why is it taking so long for this? So that's what I'm now trying to push it through. So it is at a good place for it to be working group adopted, and that's my ask. So, and next slide. Exactly. So, any question, comments?
Sue, you can go ahead with your question.
Just a comment. I did walk through this with Ali. His previous version included all of the changes, but I do recommend we dually call it in IDR and BEST. But I have no other comments, Ali.
Sure.
And quick question maybe to Andrew. Do we have also at this stage to do some security review as well?
I always recommend it. I mean, the way that I look at this, as you know, we're asking for at least early reviews of documents, before they come to the ADs. The earlier you get those done, so long as it's a stable draft, the better, because it allows things to be fixed. If it comes with the security reviews, etc., before it gets to the ADs as well, it does prevent a bit of a delay. It speeds things up. So if you can, it would be a good idea.
Okay. Thank you. Any further question for this draft? Thanks a lot, Ali.
Thank you.
Next speaker is Ketan.
Hi, Ketan Talaulikar, Cisco. I'm presenting on behalf of co-authors. Next slide, please. Okay, so to provide some background on this draft, many vendors have been implementing, and there have been interop testing for RFC 9252 that that was output from this working group. And specifically related to the N.DT2M, which is the procedures for the EVPN route type 1 and 3 for the bump traffic, ESI filtering, those aspects. What we all feel that they were not detailed enough in the RFC. There are many things involved there, and there are certainly ambiguities that we realized, talking amongst ourselves. Plus, examples were required to also give more clarity. And because RFC 9252 covered really a vast range of BGP services, it probably didn't do justice. So mea culpa. So also there was an issue there that we could take the two route seeds advertised in the route type 1 and 3, and we could do like a X or this thing, exclusive or logical or, sorry. But that works only if the SID structure, so the structure of SID is identical in both the route types, and then for all the segments, all the BDs. That's not a good assumption to carry forward. So that's another thing that we want to try and fix here.
Yeah, I'm sorry, I lost a network connection. I'm reconnecting.
No, so let me wait for it to, yeah. So what the previous one, please. Yeah. So what we are trying to, what is specified in this draft is a more generic mechanism of how to pick the argument which is signaled from in one route type and place it in the SID of the route type 3, right, in the right position. And this way it works across, different types of SID formats that may be used. So what this draft would do is we are proposing that this updates RFC 9252 for specifically for the procedures related to route EVPN route types 1 and 3 signaling. Next slide. So just a quick recap. The purpose of this advertisement of SIDs, SRv6 SIDs in these two route types is we have the ESAD route type 1, which has this n.dt2m. It carries this arg.fe2, which is what was defined in the network programming RFC 8986. And this is what is used for ESI filtering. The inclusive multicast route type 3 carries the locator and function part of the SID. And this is also it provides the structure of the SID. So this is like the receptacle and the argument is going to be placed inside this SID. Next slide. So the draft has a lot more details, but we thought that it would be good to just share the update in the form of examples here. And these are also there in the draft. So what this means is when we are doing ESI filtering, then this is the way the routes are advertised. Specifically here, we're showing the BGP prefixed attribute, which is carrying the SID. The NLRI and other things are unchanged. So if you see the SID, route type 1 carries the argument, and the route type 3 carries the locator and the function part of it. And the structure and the argument size are given there. Okay. Next slide. When there is no ESI filtering, let's say, or there is no multi-homing, then there is no SID to be conveyed. And this was there in RFC 9252, but it was not very maybe more precise on what is to be done. So this is how the advertisements would look. In this case, the BGP prefixed attribute is there. One of the key things is that it indicates the use of SRv6 encapsulation, right? So that's the reason why it's there. But what's going to be used is just the SID locator and function in the route type 3. There is no ESI filtering here. Next slide. So, and then there is a key part. So those were the advertisement of the two routes. But then there is a section which covers in more detail the processing on the ingress P, which is receiving these two routes, and how the P can put these two routes together to form the SRv6 SID, along with the argument that would actually go in the packet, right? So there is a checking between these two route types to see whether argument is received in the route type 1, right? First, whether route type 3 needs the SID needs an argument or is able to handle the argument. Then look for it in the route type 1. If we find a matching route type 1 and the argument lengths align, then we place the argument after the locator and the function part. Okay. So the last part in the red, which is how this encoding is done, is what's a key processing change from RFC 9252, where it says you just do ORing. Okay. Next slide. So there is no like new TLVs or anything of that sort. It's all procedural clarifications. And if implementation is there which is supporting, which does follow 9252, the logical ORing, then sending advertisements in this form still works. So it's backward compatible as long as the SID structures are the same. Next slide is, I think, last slide. So seeking working group review and inputs, also offline or on the list. And then I know this is the first time we are presenting, but we would like to consider for sort of an expedited adoption, because we are trying to fix something that we put out there. Yeah. Questions?
Okay. Kazeng, you are the first one in the queue.
Okay, this is Ka Zhang from Huawei, and I have questions about the argument length for the end.dt2m. The first is that for the argument length, I think for one service, the argument length should not be different from the single homing and multi-homing service, because in active network, the service may switch from single homing and multi-homing, and if the argument length is different, then the seed may be changed and redistribute during the switch. That may cause a problem. And the second question is for the receiver of the service. I think on the ingress PE node, it just need to encapsulate the whole seed, whether to use the ESI root attribute or not. And so I think it may be not necessary to check the argument length of the seed.
Okay. So if I understood, I'll answer the second question first. The second question about why we need that prefixed attribute. Could you, sorry. Was it why we need the prefixed attribute in the, when we are not doing ESI filtering? Was that the question?
Sorry.
Okay, maybe we can take it on the list.
Okay.
Yeah, you can probably discuss in the list.
Okay.
Next one, Zeng. Zeng, you can unmute yourself and ask your question. Hello, go ahead. We are not able to hear you.
Hello, can you hear me?
Yeah, we can hear you now. Go ahead.
Okay. I have a question about the AD per yes route. As you said, when ESI filtering is in use, the ESAD route should include the prefixed and the seed structure. However, the ESAD routes with the same ESI could have different locators. In this condition, how to construct the AD per yes route, how to fill the field of the sub-TLV, and which locator should be used?
So the route type 1 does not carry any locator information. It's just the argument. So that's one part. The second thing is that it's probably some of this is implementation specific. Your implementation could have the same argument, right, for all the locators, or they could have different for different locators. So based on that, you need to advertise maybe one or more ES per AD, and then you can use route targets to associate with the correct route type 3s, right? So those are more of implementation choices, I think.
Okay.
Yeah.
Okay, next one, Wenyan, but very, very fast, please.
Okay, I have a question. I read the documents, and I found that the documents have a description is the AR size should be multi of 8. So my question is it possible to change the shield to may? Because the use of the shield may lead to the theta west, and I think it's not flexible. Thank you.
So if I understand your question is, it should be okay if it was the route argument advertised in the route type 1 is of a smaller size than what's
Yeah.
in the route type. Is that sure? I mean, we can discuss it. Thanks.
Okay.
Because of the request that you have done, I would like to do a quick poll if there are some people in the working group that could object to a working group adoption for this document. So let me open the tool, and in the room you can use your hand if you don't have the app. So you say raise hand if you object. Do not raise hand if you don't object.
So, and just to clarify, I mean, the adoption is that this is something that we need to solve or address, and the solution is, for the working group to work out. Yeah,
of course. Okay, thank you. Next speaker is Jorge.
Good morning, everyone. My name is Jorge Rabadan. I'm presenting this interdomain option B solution for EVPN on behalf of my co-authors, Sentin and Ali. Next slide, please. So a short agenda. First point, why do we need it? Why do we need these documents? Second point is, what is this document about? And third, what do we ask the working group? Next slide, please. So the main reason why we need this document is because there was no, the interdomain option B solution for EVPN was, there were several pieces scattered throughout, different documents, but there was not a single document collecting all the issues in the EVPN procedures. So this document does actually that thing. It's basically an informational document. It does not create new procedures, at least for the moment. It summarizes the impact of the interdomain option B connectivity in EVPN procedures for all the EVPN services, analyzes potential solutions based on the existing specifications, and in some cases with some local implementations. Next slide, please. So the models or the diagrams that we use in the document is basically what you have here on the slide. On the left-hand side is basically a classic interdomain option B, where the border routers are ABRs and they connect different IGP domains. On the right-hand side, you have a traditional inter-AS model B solution, where the border routers interconnect routers in different autonomous systems. One thing to bear in mind is in this document, when we talk about VERFs, it's not only an IP VERF, but can also be a MAC VERF or VPWS. So we try to generalize all the procedures for the three types. And a label here, since we are talking about EVPN, can be a 20-bit label, MPLS label, or a 24-bit label, which is a VNI. Next slide, please. So from a very high level, we all know what the option B procedures are on the border routers. And basically, the border routers, they will accept any EVPN route. And for each route, they will extract the EVPN label, program a label swap operation, and re-advertise the EVPN route with NextHop self and a locally generated EVPN label. Now, in the data path, the border router will pop the transport labels, if any, swaps the EVPN label, pushes new transport labels when forwarding to an adjacent domain. One thing to take into account, though, is that if there are more labels at the bottom of the stack, the border router will have to preserve the labels. That's the case of the ESI labels, for instance. The document also has some specifics for labeled routes, and something that it has to be spelled out is that if a given EVPN labeled route basically uses EVPN labels that are not used to forward packets between domains, those are not extracted by the border router. That's the case for ESI labels or for E3 labels. For EVPN labels that are used to forward packets, they need to be extracted and programmed. Then there are also some comments or specifics for unlabeled routes. For instance, routes type 678. We only do an NextHop self operation on those. Next slide, please. All right, so when you do inter-domain option B, basically this has an impact on some EVPN procedures. For instance, multi-homing. The impact is described in RFC 8365, section 10.2.2 for MAC IP routes, but the same issue exists for IP prefix routes in the IP aliasing draft. The main issue is that mass withdraw is not supported. And the reason why is if you take the example in the diagram where you have two egress Ps multi-home to the same CE, and the ingress P is in a different domain. Basically, the ingress P, in order to do mass withdrawal, it has to correlate the MAC routes with non-zero ESI with the AD per ES routes coming from the same egress P. Due to the fact that the AD per ES route, the only identification of the originating IP is the NextHop, the ingress P cannot do the correlation because obviously the border routers are changing the NextHop along the way. As a result, mass withdrawal is not possible. So the document has three potential solutions for this in section 3.1. One option is the originating P attribute that is specified in this EVPN option B draft that we need to resurrect. Separate option is to use the RD administrator subfill solution on the AD routes, on the AD per ES routes. And there is another suggested solution, which is based on the what we call the EVPN instance route distinguisher solution. That's for the mass withdrawal procedures. For aliasing and backup, those are supported by the solution as described in RFC 8365, section 10.2. So basically, the only caveat here is that, again, the ingress PE for the non-zero ESI MAC route, it has to resolve that with a receiving AD per ES route from the same egress PE, right? But that resolution, as described in this document, can be a loose resolution. So if you receive at least one AD per ES route, for the same Ethernet segment and NextHop as the MAC route, and with the appropriate route target, then you can consider that you can resolve the route. Otherwise, you can also use the same methods that we are describing in section 3.1 to identify the egress PE. Next slide, please. If we continue with multi-homing, we also analyze the impact of inter-domain option B on DF election, ACTF capability in split horizon. DF election per se is unaffected. This is due to the fact that the Ethernet segment route that we use for DF election has an originating IP, which is not being changed by the border routers. However, the attachment circuit DF election capability that is defined in RFC 8584 is impacted because, again, you rely on the AD per ES routes to modify your candidate list. Solutions, basically, an easy one is to disable the IETF capability, right, on those Ethernet segments. And the second solution is actually go back to the methods that we describe in section 3.1. Now, for the split horizon filtering, it has an impact. And again, if you go back to this diagram, suppose you have a P1 and P2 multi-home to the same CE, and they are attached to different domains, right? So there are two possibilities. You either use an ESI-based split horizon filtering, or you use local bias, right, depending on the transport. So if you use the former one, so ESI-based split horizon, again, you need to correlate IMET routes with the received AD per ES routes to find the ESI label. So in order to do that, you need to go back to the methods in section 3.1 of this document. Or an easy solution is you can use domain-wide common block same ESI labels for all the Ps attached to the same Ethernet segment. And then you no longer need to do this correlation because you already know what the ESI label is going to be. For local bias, the border router needs to preserve the outer source IP address, which might be challenging in some cases. Next slide, please.
You have less than 3 minutes left.
Got you. Yeah, we also analyze the impact on end-to-end load balancing, depending on the transport type. We use things like the flow label, control word, and entropy information on the source UDP port for IP tunnels. So all those must be preserved by the border router, right? It's something like kind of obvious, but it was never spelled out in any specification. Next slide, please. We also analyze the impact on E3 procedures. So EVP and E3 makes use of ingress filtering for unicast for to avoid leaf-to-leaf communication, and also makes use of egress filtering for BUM leaf-to-leaf filtering. So the unicast filtering is fine because it happens at the ingress, so we have no issue with that. And the BUM egress filtering is the one we are concerned about. And again, we use the E3 label that is signaling the AD per ES route. And again, the ingress P needs to correlate the received IMET route with the received AD per ES route from the same egress P. And there you go again, we have the same issue. So we suggest some solutions in the document, the ones that you have highlighted here, but you can read it on the document, of course. Next slide, please.
You will have to conclude, Jorge, okay. I'm sorry.
We analyze other aspects and basically next slide. Yeah, so we will add more details in future versions, but basically we need to request feedback from the working group. And if there are implementations, we basically put all the issues that we know based on the implementations we know. But if there are other implementations and there are issues identified, please let us know. Thank you.
Sasha, go ahead quickly with your question, please.
Hi, Sasha Weinstein. If you can scroll back to the first slide when mass withdrawal is mentioned. Yeah. You mentioned here mass withdrawal from MAC IP and IP prefix routes. I think that there is a problem with mass withdrawal for IP prefix routes, a generic problem, because at least in the case in the what is known as interfaceless IPVRF to IPVRF scenario, these routes do not carry any ESI in their NRLI. And they cannot carry it because the 9136 clearly states that if ESI is non-zero in the NRLI of these routes, then label in these routes, which is essential in the scenario I'm speaking about, is don't care. So I think this is a common problem that has to be addressed in a few cases, how to identify IP prefix, associate IP prefix routes with an SI if ESI and the RLI cannot be used.
Yeah, I was referring specifically to the IP aliasing draft, which uses non-zero ESI with IP prefix routes. Yeah.
Thank you, Jorge.
Yeah, thank you.
Next speaker, Sheng Wang.
I'm Chang Wanlin from New 3C Technology. I'm going to talk about SRv6 SOIC flag extension for multi-homed SRv6 BGP service. Next slide.
1 second.
In multi-homing scenarios, the ingress PE can send traffic to the egress PE in load selling mode or active hot standby mode. Multi-egress PEs can also implement local protection when C-side link fail. So to meet the different requirements, the egress PE need to log and advertise multi-services for the same service. This draft describes the two use cases for the encast and bypass services, and propose to define new flags when advertising these two types of services through BBP message. Next slide. This is use case of any cast services. C3 is multi-homed to P3 and P4. P3 and P4 allocate unicast services for the VPN seed, such as and DT4, and P3 and P4 can allocate any cast services with the same value. Any cast need to be allocated from another locator. Egress PE advertised both anycast and unicast through BBP service L3 service tier with also ingress P1 and P2 have different routing policies to select next hop, result in using different services to forward traffic. For example, P1 used anycast services, and the traffic can be forwarded to P3 and P4 in load shared manner. P2 can deploy the VPN service fast rerouting to use the services of P3 as prime next hop and P4 as backup next hop. Next slide. Use case 2, bypass service seed. P3 and P4 can learn each other's services and can use each other's services as implement the local protection for C-side link failure. When the C-side link of P3 fails, P1 is not aware of the failure immediately and continue to forward the packet to P3. P3 can use the services of P4 to send the traffic to P4 and continue to forward this packet to C3. However, if the link P3 to C3 and P4 to C3 fall at the same time, such as the node of C3 fall down, so the loops occurs between P3 and P4 until routing convergence. So we need additional bypass services to avoid loops. Bypass services has no backup next hop. We can see it in the following. Next slide. Egress P allocate bypass services and advertise it. Ingress P always use unicast and anycast services to forward traffic. Egress P use each other bypass services as backup desktop to CE. Bypass services has no backup desktop. When the C side of P3 failed, use the P4's bypass set to send the traffic. If the C side of P4 also failed at this time, so P4 has no backup for local bypass set, so P4 will discuss the traffic, such to avoid a loop between P3 and P4. The link failure on the C side is not easy for the ingress P to detect. So in multi-home scenarios using bypass services, egress P could implement local protection and avoid traffic being discussed during the ingress P's procession. Next slide.
Please try to go fast because we have several questions.
Yeah, sure. This draft proposed to define two new flags in SRv6 service set flag field. A and B flag. A flag, anycast flag, when set the associated set is anycast. B flag, bypass flag. When set the associated set is for bypass usage without the local backup protection. These two flags cannot be set for the same service set. Next. Finally, we see the backwards as in FC 19.2.15.2 about multiple SRv6 sets. When multiple SRv6 set information subtheory are present, the ingress P should use the first SRv6 sets of the subtheory, or an implementation may provide a local policy to override this selection. When the egress P advertise multiple services, the unicast services need to be carried in the first instance of subtheory. Any unloaded flags in the SRv6 services must be ignored by the receiver. So when there are P routers not supporting the anycast or B bypass flags, the egress P may expect those routers to use the first set and ignore the new defined flags.
Okay, it's time to conclude.
Next. Any question, comment?
Yeah, Ketan,
thanks.
please start with your question and be fast.
Yeah. If you can go to the slide number 4 or 5, I think it's a bypass. Yeah. So in this case, my understanding is that there are two SIDs signaled from the P3 and P4 to the P1. So it is the P1 that has to start using the other SID. Is the SID being changed by the P1 in the packet when the failure happens?
Yeah, P3 and P4 log the two services, bypass it and unicast services. Then P3 and P4 use another bypass it as backup to the C3 link. As in egress node P1, it not use the bypass set. Just the P3 and P4 use the bypass set.
Okay, so when it detects, it uses the bypass set. Okay, and regarding the anycast flag, second question, why do we need that flag, the anycast flag, to be indicated?
Anycast locator may be advertised in IGP, but the IGP loader may be in some scenarios maybe the underlay load not IGP load, so we can't get the service is anycast or unicast.
But why is that indication required in BGP?
We can.
I need to want to give time for Horace, but
Yeah. We need to take time for others.
maybe you can explain on the. I can ask on the list as well.
Yes, thanks.
Jorge?
Jorge Rabadan, Nokia. So my question is this for layer 3 behaviors or also EVPN layer 2 behaviors?
Is one behaviors. We not extend the SRv6 behavior. The behavior is same. Is same. We just use the flag to extend the flag to distinguish these two services.
Yeah, but if you intend to use this for instance, EVPN fast reroute, Luke was presenting a solution, which is, in my opinion, way more efficient because you use a single SID, right?
Oh.
Or a single locator.
Yeah.
That's one comment. And even for layer 3, wouldn't you solve it if you use an AND-DX 4 or 6 behavior? And then basically you solve the loop situation, right? You can go to P3 and then go to P4, and P4 will always send to this C3 or drop the traffic. So I don't understand why you need a new bypass service SID for this.
I will think more and reply in the
Yeah,
mail list.
please check
Thank
this
you.
offline. Look, Andre, very, very fast.
I'll be brief. Yeah. Thank you for this presentation. I think it's addressing a common problem. Maybe we can discuss after, because there's two issues that I see in this proposal. The first one is you're installing a backup path only on the active, pointing to the backup, but based on the bypass service SID, you decide not to install the backup from the backup path to the main path. Is that correct? And we can talk offline after.
Yes.
The second question is, when you do the reroute from P3 to P4, in EVPN, if it's an L2 service, you do have the problem that the P4 to CE3 link could be DF non-elected. So the traffic arriving at P4 will get blocked and dropped before control plane has time to readjust.
Yeah.
So I would like, actually, after the session, we can discuss it outside.
Yeah, thanks.
Yep, thank you.
Thanks a lot.
Yeah.
Last speaker, see you.
Hello, everyone. I'm going to introduce about our draft called MVP Upstream Designated Forward Selection. So I'm here on behalf of my co-author, Fang Hong. So next slide, please. Firstly, let's have a brief recap about this draft. Previously, we proposed our procedure and MVPN extension to perform the upstream ingress site designated forward selection. So at each route PE, the primary and standby DF can be elected consistently. And we also introduced an RPF checklist mechanism so that when the failure occurs, the multicast traffic can be received on the leave PE from the backup tunnel quickly. And we also introduced about the BFD session established between the primary and standby PE so that the failure can be detected quickly. And this time, I will mainly introduce about the rest part of our draft and our updates on those questions mentioned in the mail list. So next slide, please. So firstly, this is updates about the question that the difference between our draft and IFC 9026. So this time we update it as when the route PE received the SID multicast route from the leaf PE, it will only forward the CPIM join towards the client network if it is a primary or standby IDF. So in this way, only the primary and standby IDF will receive the multi-traffic. And therefore, when the failure occurs, the new standby IDF in the bottom of the figure will need to send a CPIM join again. Okay, next slide, please. So next part is about the CMRD problem. So as you can see from the top of the figure, there are only two key fields, which is the RD and the IP prefix of the UMH root. Therefore, when the RD are configured the same at different PE, the UMH root sent by them will be same from perspective of a leaf PE. But our premise of the procedure was that we need distinct PE, distinct RD on different PE. Therefore, we proposed a new format of the UMH root. And the new UMH root will just carry the originator IP address as a key field, so that the leaf PE will just process different UMH root. And the new UMH root will be exchanged among those multi-homes PE. And it has higher priority than existing UMH root. So next slide, please. Here we discuss about the non-segmented inter-AS scenario. So as we all know, there is a problem that the 4-octet source AS field cannot hold the 16-octet IPv6 address. And it will result that it is hard to distinguish between two C multicast roots in the CS group granularity. So our solution is to use the root distinguisher extended community. It will carry it in, with the intra-AS AD root or wildcard SPMSI AD roots, and the value will be a the global administrator field of this community will be a 4-octet global unique value. And when the leaf P received the AD root, it will just fill the source AS with the root distinguisher value into its C multicast root. So next slide, please. And here we talk about the root P explicit tracking function in the segmented inter-AS scenario. In the segmented inter-AS scenario, different intra-AS AD roots will be aggregated into one inter-AS root, and the originator IP's information will be discarded. And the leaf P will not be able to distinguish the multicast traffic from different root PEs. So we proposed two solutions. The first solution is to use the wildcard SPMS AD root proposed in IFC 6625. And it mentions that the wildcard SPMS AD root will not be aggregated at ASBR. The second solution is to use the PE distinguisher labels attribute proposed in IFC 6514. And the PE distinguisher label will be assigned at the ASBR for different root PE. So they will be carried with the inter-AS AD root at the AS point. When multicast traffic arrives at the ASBR, they will be processed that the label assigned previously will be added into its label stack as an inner label. In this way, the leaf PE can recognize the source of the multicast traffic, and the RPF checklist can be performed accordingly. So second slide. Next slide, please. So finally, we just update the backup capability, compatibility function into our draft. Recently, it mainly discussed the situation that one of the roots and leaf PE may not support the previous IDF election function. And we propose the warm PMSI tunnel attribute to initiate the establishment of the warm primary and backup P tree. And we also mentioned about the solution to the problem that leaf PE may choose different root PE. And as you can see in the figure, there are three conditions. The top leaf PE, it supports the IDF election, but it did not connect to the primary IDF, so it cannot receive traffic from the primary P tunnel. So the P tunnel will just revert back to the normal P tunnel. And the middle three leaf P they support, and they are all connected to both primary and standby IDF. So both the warm primary and backup P tree are established here, but only the primary P tree is used to forward the traffic. And at the bottom of the figure, the leaf P does not support the IDF, so it will also revert back to the normal P tree. Okay, next slide, please. So as you can see, we have just evolved our draft since IETF 113, and we are looking forward to more bit-based working group reviews and comments. And this time we would like to call for an adoption. Okay.
Any comment? No. So thank you, everyone. So we are at the end of this session, and we are on time. Thanks a lot, and see you or talk to you in San Francisco.
Yeah, sure.
Give me 2 minutes. I want to speak to Kevin. And then walk with me while I go fight. How's that?
Hey, hi, how are you? Sorry, I buried it. Yeah, yeah. So yeah, I have to run now, but let's definitely sync up either by email or eventually call or something because trying to address the same problem, right? You have the Anycast part, but at least the FRR part or the redirect part, I address the same problem. So we could possibly work together on that one, right? Because like when I was going through your draft, it seems that there's some things that like the no reroute or no like the loop or whatever. We clearly like we know we have to not do that. Yeah. Yeah. Correct. Yes.
This is failed. Backup is
correct. Yeah.
So
But,
this is
so how do you avoid that?
This is the process of bypassing. This process
Yeah. But how does he know that he failed?
So, so as a service showing flag, this flag.
Yeah.
The flag is bypass flag. Bypass.
Yeah, but that also means that this egress node has to know that this one has failed also. How do they know? I agree they can know in BGP, but that's slow. Yeah.